Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem of quantum mechanics. Problem having been chosen from the book Quantum Mechanics Concepts and Applications by Nordine Zettley. Okay. First we come to its statement. Calculate the de Broglie wavelength for Part A proton of kinetic energy 70 million electron volt, and Part B, a 100-gram bullet moving at 900 meter per second. Okay, here 100 gram is equal to 100 divided by 1000 equal to 0.1 kilogram. Okay, we will use 0.1 kilogram instead of 100 gram. Okay, so quite easy. We have to find the de Broglie wavelength. Okay, number in part A for a proton of kinetic energy 70 million electron volt, and in part B a 100-gram bullet moving at 900 meter per second. Okay, in part A kinetic energy is given, in part B velocity is given. Solution. We know that each material particle of momentum P, okay, here we can denote P either by capital letter or by an arrowhead in order to show that it is a vector quantity. Okay, we know that each material particle of momentum P behaves as a group of waves, that is matter waves, whose wavelength lambda and wave vector k, that is either k bold or k with an arrowhead on it, okay, are given as. Okay, we know that each material particle of momentum P behaves as a group of waves, that is matter waves, whose wavelength lambda and wave vector k are given as lambda equal to h over, lambda is equal to h cut over p. Okay, no, lambda is equal to h over p and k is equal to p over h cut. Okay, wavelength lambda is equal to Planck's constant h divided by momentum p, and wave vector k is equal to momentum p vector divided by h cut or h reduced. Okay, where h cut or h reduced is Planck's constant divided by 2 pi. Okay, h cut is equal to h divided, where h cut is equal to h divided by 2 pi. Okay, this is called h cut or h reduced, while simply h is Planck's constant and its value is given in a table which is included in our problem at the end. We go to that table. Okay, this is the table, and in this table value of Planck's constant is given this. Okay, this value will be used in this problem. Okay, so lambda is equal to h over p and k vector is equal to p vector over h cut, where h cut is equal to h over 2 pi. This is known as the de Broglie relation, which connects the momentum of a particle with the wavelength and wave vector of the wave corresponding to this particle. Okay, this is known as the de Broglie relation, which connects the momentum of a particle with the wavelength. Here is wavelength lambda is equal to h over p, and wave vector of the wave corresponding to this particle, that is k equal to p over h cut. Okay, now we move further. Now we come towards part A, in which proton is under consideration, while in part B bullet is under consideration. Let T be the kinetic energy of the proton and MP, where P is written as a subscript of M, be the mass of the proton. Yes, students, actually here we are assuming that we will denote kinetic energy by T is there because in various branches of physics we denote kinetic energy by various letters in different ways. Okay, so it is better to explain in the beginning that here T is denoting kinetic energy and MP, where P is written as a subscript of M, is denoting mass of the proton. Okay, T, kinetic energy of the proton, is given in this statement, while mass MP, that is mass of the proton, proton mass equal to this, proton mass MP equal to this and this, two equivalent units. Okay, from here we will use the value of mass of the proton. let T be the kinetic energy of the proton and MP be the mass of the proton. Then we know that kinetic energy is equal to half mv square. So according to that formula, here in place of kinetic energy we have used the symbol T. So T becomes equal to half mpv square. This becomes equal to half mp into p square divided by mp square, because dear students, we know that momentum p is equal to mass into velocity. Okay, so from this multiplication, if we keep velocity on one side, then v will become equal to p over m. Okay, so here in place of p, mp, that is mass of the proton, is under consideration. So v square will take this form. Okay, p square divided by mp square. Okay, this v, okay, we know that linear momentum p is equal to mv. Okay, from that expression v will be equal to p over m. Okay, in place of m, here mp is being used, so v square will be equal to p square over mp square. Here one mp will be cancelled with one proton mass, and hence we will be left with kinetic energy T equal to p square over 2mp. Okay, this implies that if we keep p square on one side, then it will be equal to 2mpt. Okay, this 2mp will be multiplied with this t, and hence p square will be equal to 2mpt. This implies that if we take under root of both sides, then this square will vanish and simply p will appear. Okay, so p becomes equal to 2mpt under root. Okay, now because lambda is equal to h over p, so here in place of simply lambda, we are using lambda p, because here wavelength of proton is under consideration, so we can use p as a subscript of lambda. Okay, so wavelength of proton lambda p is equal to Planck's constant h divided by momentum p. In the next step, we have multiplied and divided by c both sides, hc over pc. Okay, yes students, in the table combined value of hc, that is Planck's constant h divided by speed of light c. Okay, these both values are given separately as well as given in this table. Okay, here c is given, here h is given, okay, and here hc is given. Okay, not only in terms of electron volt nanometer, but also in terms of million electron volt femtometer. Okay, So here what we have done, in place of HC we have used its value from that table which has been shown at the end of this problem. Okay, divided by we have already calculated P. Okay, but it is only P. When we will multiply P by C, when we will multiply P by C, then it will become HC value is put here divided by this is P and this is C. Okay, because we have multiplied and divided by C. And in place of HC we have used its value. Okay, now dear students, this C can be written as a under root of C square. Okay, so if we insert this C inside this sign of under root, then it will be entered in this sign of under root as a C square. Okay, so it will become 2t into mpc square. Okay, now the value of this mpc square is given in the table which we have shown in the end of this problem. Okay, here we have used 938 million electron volt. 938 938.3 MeV over C square. Okay, proton mass MP, this is equal to 938.3 MeV over C square. Okay, so quite simple. Here in the numerator we have replaced this HC according to the table, and in the denominator in place of T we have used its value which is given in the statement, and in place of MPC square we have used its value, that is 938 million electron volt. In table it is given that million electron volt per C square. Million electron volt per C square. Okay, this C square will be cancelled out. So in place of MPC square we have simply write 938 million electron volt. Okay, its C square denominator is cancelled with this. Okay, so this MPC square will be written in this form, 938 million electron volt. Okay, because MP is equal to 938 million electron volt per C square. Then we will put here C square will be cancelled with C square. Okay, now after simplifying we get this expression. Okay, because here dear students, MeV with when multiplied with MeV it will become million electron volt square, and under root of square is simply that value. So here MeV million electron volt will be brought outside the under root, and after simplifying we will get this. Okay, we know that 10 raised to the power minus 15 is called femto. Okay, so our wavelength, that is wavelength of proton, becomes equal to 3.42 into 10 raised to the power minus 15 meter, and it can also be called femtometer. Okay, both answers are correct. Okay, now we come towards the bullet case. Now lambda b, that is wavelength of bullet, is equal to h over p is equal to h over mv, because momentum is equal to mass into velocity. Here mass is 100 gram or 0.1 kilogram, and v is given as 900 meter per second, and value of h is taken from the table. Okay, So after simplifying, it becomes equal to 7.36 into 10 raised to the power minus 36 meter. Actually, dear students, this second last expression has been changed into this 7.36. Due to this reason, this 34 has increased to minus 36. Now it is given that during this simplification, this formula has been used because these three dots indicate since or because joule is equal to Newton into meter and Newton is equal to kilogram meter per second square. This implies that joule is equal to kilogram meter square per second square. Okay, so using this formula here, these units are cancelled and we are left with 7.36 into 10 raised to the power minus 36 meter. And this is the end of our problem. Till next problem, till next video, Allah Hafiz.